In this video, we are going to be examining the question, what is a reference angle? What is a reference angle? Well, here is a definition of a reference angle. For any angle in standard position, the reference angle is the smallest angle that takes us back to the x-axis. Now, what does that mean? Let's take a look at an example to see exactly what that means. I'm going to draw a unit circle here, and we're going to find, let's find the reference angle for 110 degrees. To do that, you begin by drawing a unit circle. We can estimate about where 110 is. This is, of course, 90, which means that a bit more is 110. So right here we have an angle of 110. What does it mean for this angle to be in standard position? See, in the definition it refers to standard position right here. Well, 110 is in standard position because one side of it is on the positive x-axis. The vertex of the angle is at the origin, and here is its terminal side. We call that the terminal point, by the way. So, what is the smallest angle that takes us from the terminal side back to the x-axis? Well, clearly we could go this way or we could go this way. The smallest angle that takes us back to the x-axis is this one. And since there is 180 degrees from here to there, there must be 70 degrees here, which means that the reference angle for 110 is 70 degrees. Take a look at another example. This time, let's find the reference angle for, say, 120 degrees. Again, we draw a unit circle. And we'll estimate where 120 degrees is. Perhaps it's right about there. It's in standard position since one side is the x-axis, its vertex is at the origin, and there is the terminal side. So we're saying that's about 120 degrees. What would the reference angle be? Well, the reference angle is the shortest angle that takes us from the terminal side back to the x-axis. That's clearly this angle. And so here we're saying that this must be, well, 120 plus 60 will give me 180. So the reference angle in this case must be 60 degrees. Here is why reference angles can be so useful. You see, we know a great deal about the sine, the cosine, and the tangent of 60 degrees. If I draw in 60 degrees in standard position, this is the x-axis, and here it is in standard position, we can identify what the cosine and the sine of 60 degrees are. The cosine of 60 degrees is, of course, 1/2. And the sine of 60 degrees is radical 3 over 2. That information is enough to find the cosine and the sine of 120. Because it should be fairly apparent to you that 120 is a reflection of its reference angle 60 right here. So, what will the cosine and the sine of 120 be? since we're at the since here the x-coordinate is 1/2, and this is a reflection, now that we're on the negative side, the cosine of 120 must be a negative 1/2. This reflection is across the y-axis, so the y values are not changing, which means that the sine of 120 is also radical 3 over 2. This is a good example to illustrate how being able to find the reference angle of an angle can oftentimes help you to know what is the cosine and the sine for that angle. Here is another example to show how that can work. Let's try to find the sine of 225 degrees. Well, I don't know off the top of my head what the sine of 225 degrees is, but maybe I could find its reference angle and that will help. Let's try. So I'm going to draw in a unit circle here. And my goal is to first find its reference angle. I'll estimate where 225 is. 225 appears to be, well, it's larger than 180, but it isn't so much as 270, so I'm going to estimate that it's right about here. It's in standard position, so that means one side is on the x-axis, its vertex is at the origin, and it goes to its terminal side. So this is our picture of 225 degrees. What is its reference angle? Well, the reference angle is the shortest angle which takes us from the terminal side back to the x-axis. Clearly, we would not go this way. The shortest distance is this one right here. And what is the size of this angle? Well, from there to there is 180. From here to there is 225. So if I take 225 and I subtract 180, that will leave me with the size of this angle, which in this case ends up becoming 45 degrees. Which means that the reference angle for 225 is 45 degrees here. That's excellent because we know a lot about the cosine and the sine of 45 degrees. The cosine of 45 degrees is radical 2 over 2. The sine of 45 degrees is radical 2 over 2. And we can use the knowledge that we have about these coordinates to find these coordinates. Let's see. It appears that we are reflecting this point through the origin, which means that we'll have the same numbers except we will have to change the SIGN of both. So this one will be negative radical 2 over 2 and negative radical 2 over 2. Which of these is the sine? Well, the cosine and the sine. There is the sine, and it's asking us to find the sine of 225. And so the sine of 225 is equal to, it's showing us right there, it is negative radical 2 over 2.